Okay. Hi everyone. Welcome to the Machine Learning Roadmap from Zero to Hero. This is event organized by GDG Wrocław. And today's speaker is Ruqiya Bin Safi, Google developer expert in machine learning, R&D specialist and consultant in terms of data science, ML and AI. She is also a Google Cloud developer community trainer and Women Techmakers Jeddah organizer. She has led the multiple machine learning trainings and workshops. And I encourage you to ask questions because two of them, which is the most relevant, you can get the JetBrains license, the license for the one product from JetBrains. Okay, so Ruqiya, the stage is yours.
Hello, everyone. I am so glad to be one of the speaker in this session. Thank you to all attendees, which you enjoy and spend useful time in this session. I love Poland and I hope to visit it as soon as possible. I am really excited about talking about something really I love, machine learning. Which you are excited too. Today, I want to give you a big picture or overview about machine learning and how to get started, the plan, the roadmap to self-learning. I will explain the big picture and explain the general steps to create the machine learning project. So let us start. This is my handle on Twitter if you want to connect with me or have any questions. Today agenda. What is the machine learning? Why we need to learn machine learning? The roadmap, if anyone wants to self-learning, plan for self-learning, steps for machine learning project. These steps contain many topics or many steps, define the problem or framing the problem, prepare the data, explore exploratory data analysis, clean and deal with misvalue, clean the data, transform the data, visualize the data, choose the model and train it, test and evaluate the model, and use the model for prediction, finally deploy the model. Let us start with the question, what is the machine learning? The machine learning is the field to study that provide the ability to automatically learn and improve without being explicitly programmed. What I mean, or let us say, what's the difference between the traditional program and the machine learning? So, in the traditional program, we input the rule and the data. We wrote the rule and input the data. Then the output, the answers. In machine learning, no. We input the answers to learn as example and the data. So the machine learning create the rule. The rule can apply in any new data to predict something or give us the new answers for this data. So the machine learning create the rule. The rules maybe say models. So the rules mean model. So machine learning different in the traditional program because the machine learning create the rule. So why we need to learn machine learning? In this area, or in this age, multi-application. All the application, all the apps use machine learning or something related to AI, deep learning, machine learning, data science in this field. So, for example, traffic prediction, web search, when we search in the Google, we use machine learning or AI for recommendation. When you use online detection for any transaction or abnormal behavior, medical, in the medical field, we use machine learning, text and speech recognition. We use machine learning in the email spam filtering. We use machine learning, image recognition. Also, this is the application of machine learning, and so on, and so on. A lot of application we use that based on machine learning, based on AI, based on the deep learning, and so on. So if you're excited to start learning about machine learning, we need the plan. If you want to self-learning, how can start? So this is my roadmap to start. First step, you need to know about the basic concept, the relation between the sense. For example, the relation between artificial intelligence and machine learning and deep learning and data science. This is very close. So what's the machine learning technique that enable machine to behavior like human? It is like or think or like human. So this is the big part that contain the machine learning. So machine learning is subset of AI, which use a statistical method to enable machine learning to improve with experience. In the machine learning, there are deep learning, also subfield of machine learning, contain multi-layers of neural networks. And there are data science. Data science also a study of data. It is combine many domain expertise, programming, also math, statistics. This field need algorithm of machine learning to understand the data, and machine learning need the data. This data science provides understand the data, so machine learning need the data, and data science need algorithm of machine learning. So this is the field, science very close. So the first step to understand the relation between them. Then next step, start learning Python. If you already learning about Python, that is good. If you need resource, I ask them to put the slide in the chat. Here, multi-resource, multi-courses, you can use all the link to start learning. Okay, so click and this link is to go to the resource to learn data. If Python. If you already learn Python, let us move to the next step, which learn Jupyter. This is tools. We need tools to apply machine learning or to write coding. So Jupyter, Aconda, and Google Colab. And this is the easiest and famous one. This is very, very simple because just we don't need install anything, everything in the browser. So this is how can start the link. So also please check the links, and Aconda. Jupyter already built or exists in the Aconda. The fourth step, analyze and visualize the data. We need library. The famous library, there are a lot of library exist in the Python. The famous library, Panda, which use to read the data as tables, make it as a structure. So deal with data very easy. Matplotlib for visualize the data, and NumPy for math and apply mathematics and deal with the matrix and so on. So this is link is to learn about this libraries. Number 5, the 5 step machine learning concept. You have to learn the concept of machine learning, like algorithm and so on. The simplest framework or library to apply machine learning, scikit-learn. So you need to learn about scikit-learn. Scikit-learn is very easy. The easiest library to apply machine learning. This is the resource, and if you don't know a lot about math or statistics, you don't need this this knowledge about math or statistics. If you have, that is better. You can be excellent in machine learning. If you don't have, everything exists in this library or in the framework. You don't build everything from scratch. Everything exists and just import library and apply it. So if you have the knowledge in the math and statistics, that's better. Sometimes you need to learn math and statistics to be better and excellent in machine learning. If you don't have and you need to go through machine learning, you can because everything library exists. You just import the library and apply it. The 6th step, learn deep learning. So it is the final step or the big step, deep learning and neural network with TensorFlow or other deep learning framework. For example, Keras. Now Keras belong to or exist in TensorFlow framework and PyTorch. The easiest one, and from my opinion, TensorFlow and Keras. Keras very easy, just high level API, just a small command or like method or function. Very easy. Keras, because high level, you deal with high level. So you need to learn about neural network and the tools to apply neural network framework or libraries like TensorFlow plus Keras and PyTorch, and there are another Cafe, for example. Another roadmap. This is roadmap exists in the internet. It's very useful. Let us go click machine learning problems. For example, category, classification, regression, and resource to learn. If you click here, you can go through resources. For example, Python. Click here, and you can many in practice. So it is very in statistics, probability, mathematics. This is useful, but you can. But if you have this skills or knowledge, you will be excellent. So I encourage strongly to learn. But if feel it is difficult, you can pass in machine learning using the libraries that exist in the framework. Okay, let us start learning. Steps for any machine learning project. This is steps. First step, define the problem and framing the problem. Gathering the data, preparing the data, feature engineer, apply feature engineering, choose the model, training and evaluate the model, predict, use the model for prediction, and deploy the model. So this is the general steps. Maybe sometime you maybe 6 you find in some resource or books or in the article in the internet, 6 or 8 or 7, but the big picture is the same, or the general step is the same. So you can say also there are 5 steps. First step, frame the problem, get the data, explore the data, build the model, and communication. The result, or what did you learn, or what the story that exists in the data, or what you predict from the data. So in each phase, you need many skills. For example, in the last step, you need presentation to tell others what exists in the data, or what visualized in the data, or what predict from the data. For example, gathering get the data, and gathering the data, you need many skills. For example, web scrubbing, or cleaning, querying in the data base, for example, to collect the data or get the data. Also, you need many tools in each phase. You need many tools. This is for example. For example, for framing the problem, you need your brain. Think how you can define your problem. First step, define and framing the problem. What is the framing the problem? It is the first step, which is define the solution or the problem to get the solution, to solve it. So the framing way is structuring for present the problem or issue. Let us take the example. For example, the lift here or elevator. What is the problem here? Here, the problem is the elevator is too slow. So when framing the problem, it is too slow. The solution depends how the problem framing. So let us and see the solution. The solution depends how framing we framing the problem. The solution, for example, replace the lift, install strong motor. So make the elevator or the lift faster. Let us reframe the problem and observe how the solution difference. When reframe the problem, this is the new frame for the problem. The waiting is annoying. So how can find the solution? Like here, the solution, make it the time, make it faster, so don't feel the time. So the solution maybe music, maybe something else. So how we frame the problem? we can difference or get different solution depending on how define the problem or what the goal from this project or what the frame of the problem. Next step, gathering the data. In this step, we focus on getting the data. So data may be structured like database, the table in the database, or unstructured like image, voice, or semi-structured. Some files, for example, JSON file or type can be useful, and it can come from different resources and merge them together. The potential resource, for example, website, social media, open data, enterprise data, sensors, and also database, multi potential of resource, and we can merge them into data pods or data warehouse or data lake and so on. This is data gathering by ourselves. Sometimes there are data already collected. For example, if you click here, for example, casual, let us go to casual. Here already data exists and ready to use. So there are many repository contain data ready to use, and for learning. But if you have a specific project, you have to collect your data. So your data not exist in this website or repository. You have to collect your data by yourself. So now we have the data. We want to prepare the data. This is the third step. What the purpose from this step? Converting the data from initial format, which raw data, to the data that may be better for analyze or for used for training, because computer need numbers. Sometimes the data are not numbers, maybe strong or object, or we prepare data to fit to training, to fit to the model. Major task in data preparation or data, sometimes data pre-processing, called data pre-processing, ED, exploratory data analysis, data cleaning, data transform, data visualization. This is the major tasks in data preparation or data pre-processing. Let us start with exploratory data analysis, EDA. It is approach for summarize, visualize, understand. We need to understand our data set. So this is steps just for understand our data set. Next, sometime data maybe in the repository like casual, cleaning, sometimes cleaning, sometimes when gathered by ourselves, we need a lot of headache to clean it. So sometimes handle with misvalue, outlier, correct format, remove duplication. So this is steps and take a lot of time. This step take a lot of time to be ready to training or visualize or analysis. Missing data. How we can deal with missing data? Actually, 2 steps: identify missed data and deal with missed data. Now, if identify missed data, so how can deal with missed data? There are 2 methods: drop the data or replace the data. Drop the row or drop the column. Replace with maybe mean or median or frequency, or paste it other modules or other function or inference the value by ourselves. So there are actually either drop or replace. How replace? How drop? Or in each case, we take our decision if drop or replace based in this or our case or our project. Transform the data. There are 2 kinds of transformation: categorical and numeric. Let us start with categorical. If we have categorical data, we can't pass them to the model training like string or object, because a model or a computer just deal with numbers. There are mathematic operation, just so we need the numbers. So transform from object or string to number. There are a lot or many methods. One of them, label encoder, and one hot encoder. Label encoder, like this example, we have country, so we encode the string to numbers in the same column. We put the numbers in the same column. In one hot, we use just either 1 or 0. So this is the unique value in this column. Unique value, India and China and US and Japanese. So we put in them in the table, and either 1 or 0. If exists 1, if not 0. So this is one hot encoder and label encoder. Transform numeric data. There are 2 methods: normalize and binding. This normalize transform numeric data in the same scale to other numeric data, and binding transform usually the numeric data to continuous data to categorical data to discrete data or discrete numbers. Numeric. Why we need already numeric data numbers? So the computer can deal with number. So why we need to transform numeric features? Sometimes we need a very different value within the same feature. For example, city population. Many cities contain small, for example, in small numbers, and other city so far or high population. So we need in the same feature, make it in the same scale. So we apply transform or normalization. Transform, normalization the data. Sometimes with different features. So for example, age and income. So for example, if you want to visualize the age from 1 to maybe 70, and income maybe 15,000 or something. So it is very different between the range. For visualize, also for visualize, we can't visualize them clear. Binding or bucketing, for example, in the survey, we present the age as grouped. We grouped the age. So for transform continuous numerical variable to discrete bin or group. Sometimes group ages or something like in the survey. So this is bucketing for binding. Data visualization. We need the data visualization to represent graphical representation of information, the data. Usually use chart, graph, timeline, maps, and so on. The famous libraries, Matplotlib, we can click and go to documentation. Plotly, Seaborn, also you can go to documentation, and Alter. Feature engineering. What is the feature in engineering or the goal of feature engineering? It is the process to use domain knowledge of data, our domain knowledge of data to choose the features or create new feature. Why? To allow a machine learning algorithm to work more accurately. So if you use our domain knowledge to choose just few features that fit to algorithm that will be better or create new features. A lot of some of method for feature engineering, for example, create or construction, feature construction, create new feature or combine or uncombine. Sometimes combine multi-features or uncombine a feature. Or sometimes select, and this is the famous one, selection, feature selection, select from many features to a few, just few that useful. So we need just useful features. So select the feature that we feel that's useful to create our model. Choose the model. In machine learning, there are many kinds. Supervised learning, unsupervised learning, and reinforcement. So in supervised learning, there are regression and classification. Every type, a lot of for example or application, weather forecasting, market forecasting, for example, for regression. Regression deal with number, and classification with category. Also, unsupervised clustering and dimension reduction. Clustering, example, recommendation system, target market, and so on. And reinforcement, like game, robot, and so on. Let us take supervised learning. We pass input data and annotation. Annotation means example or a class or a label to the model, train the model. So when predict, say, hey model, what is this? And the model get the prediction, it is an apple. In unsupervised, there are no labels. So just input data. and the model observes the data, find the similarity between the data. So group the data based what the model observed. So this is the apple, banana, and so on. Get it in group. Reinforcement, no, it is different. There are agent and environment. Agent like game or like robot. So the agent observe, first step observe and select action. Action like go to water or fire. So every action there, in every action there are reactions. So when go to the fire, there is either reward or penalty. So the agent update the policy. So this is bad and this is good. This is bad and this is good. So every iteration iterate until reach to the optimal policy. This is reinforcement learning. Okay, we want to find a way to get the best model for our data set. So we need like roadmap just for choose the model. So let us start. If, for example, if you use scikit-learning framework, we ask about our sample is greater than 50, yes or no? Okay, just 1 minute. Okay. Okay, so say is the sample is greater than 50? So yes, go to the next questions. Is not bring more data or get more data. So let us assume it is greater than 50. So the next question, categorical or not? If yes, ask label it, have label data. If label data, we use classification. If unlabeled data, we use clustering. Okay, so if the answer of this question, category, no, we ask quantity. If yes, go to regression. If no, to go to another question, and so on. Okay. I hope it's clear. So let us start the next step for any project, steps, machine learning project. Training and evaluation. What is happening in the training? So we have raw data, train. For example, let us say we want to classification or regression, supervised learning. We have raw data and label. This is, if we have label, that is supervised learning. So after that, we select or feature extraction, feature engineering. Next, prepare our data. Let us say here prepare data, so feature extraction. So we have our feature matrix that fit to training. After training the model, choose and training the model, we get the weight of the model. We eval the model. So if the results so good, we go to prediction or to deploy the model. If the result bad or not enough good, so we have loop. So either go to training and fine-tune the hyperparameter, or choose another model, or go to the feature extraction. Maybe our feature not good for this, for apply this model. So we improve our model until we get high score or high accuracy. Then we can deploy or predict or use our model. The evaluation matrix. Every model have matrix for evaluation. For example, regression have, if you click here, we can go to see in scikit-learning. Also, TensorFlow have matrix for evaluation and so on. For regression, we have mean square error, root mean square error, and mean absolute error. This is for evaluation. That's mean what happened? We find how this is the with the green line is our predict. So we find how our predict so far from the distance, or the average of distance from the real value. In classification also there are many matrix, confusion matrix, confusion accuracy, log loss. If you click on them, you can go to the documentation. Also here you can go to documentation. In the evaluation, there are many issues. For example, underfitting and overfitting, and this is the best one. Underfitting means our model cannot generalize in the training set and the test set. So all of or most of the prediction wrong. In overfitting, doing well in training set when test it in the training set, but if you test our model in the test set, the value go to be bad, or the accuracy bad. So bad accuracy in that training set and good accuracy for training set. The best case, just right, not under, not over. Now our model ready for prediction. We can use the model for prediction. There are also some issue in the prediction when this data or the mismatches the data. Here we deploy the model or use the model for predict. This is new data. We have to apply feature extraction and apply or get the same vector. For example, here 5 numbers, and here we have showed 5 numbers in the vector, and pass them the value to the model for predict and get the label. If you pass 6 features, we go to error, or 7 or 7. We have to match the same feature matrix. Then our model ready for deploy. there are many ways to deploy your model. One of them, the easiest one, you convert the model that's built with Keras and TensorFlow by Python to JavaScript using TensorFlow.js and deploy it in GitHub pages. So we have a simple code for creating model by Python, TensorFlow, and using Keras. Then save the model and convert it to JavaScript using TensorFlow.js and deploy it in the model. Before we go to the code, I wish everything clear. If you have any question.
Okay, so thank you, Ruqiya, for joining us. Now, I encourage everyone to ask the questions because you can win the JetBrains license. Now, we'll wait a little bit for the questions because there is a delay between us sending the stream and the receivers. And don't forget that the slides for this presentation are available. We also update the description of this movie on YouTube, so everyone can also download it in the future.
Thank you so much. If you there is not a question, so I go to explain the code. Yes. I will move on the code. I think we have to finish. How many minutes left? Maybe not in our time because I think we have 15 minutes. So I will go quickly on the code. This is the demo. Before we start, we predict the home price. We will enter bedrooms. For example, we have 2 bedrooms, also 1 bathroom, the square footage 100, the grade, let's say 5, and predict. This is our project. So how we can build this project and deploy in like GitHub pages. So this is the data, which data set from Kaggle. You can click here and go to the data set. This is the steps. So for recall, we have data with label, prepare the data. Our data already prepared because it exists in Kaggle and already don't have misvalue or something that need to clean or preparation. Feature extraction and training and training, evaluating a model and use the model and deploy it. This is the steps for recall, just for recall. First step, import library. What we need exactly, we need NumPy. If you remember, NumPy to deal with mathematics and matrices, Panda to read and deal with data as tables. The easiest way for deal with the structured data. Seaborn for visualize. Matplotlib for visualize the data. TensorFlow, the framework, I choose TensorFlow, not scikit-learn, because I want to get benefit from TensorFlow and Keras and transform it from TensorFlow with Python to TensorFlow JSON, not JSON, JavaScript, sorry. Transform from TensorFlow, regular TensorFlow to TensorFlow JS. So just JavaScript. If we have JavaScript, we can deploy anywhere. the model be static. So this is the path of dataset. If you click follow, if you click here, you can go to follow the link and see the data. It is a CS file. Now we use Panda library, which adds BD. So BD read. If you stop here, you can see the documentation. Let me run all. So okay. Panda.read just and pass our data set, which exists in this link. Now we read the data as table, so it's so clear. We have 21 and 60, 13 row and 21 column. This method info, why get info, just for get us the information about data. For example, how many entry, how many column exist in the data, the type of data, the non-value. So for example, here we know this is the object. So we know if we pass the date to our model, we need to transform it to numeric, but we didn't use the date, so we will drop the date in the step of feature engineering. Check if there is null data. As you see, zero null. So is null return true or false? Sum the number of non or miss data, so 0. So our data is ready, visualize to check, ready, no miss value. So we didn't need to drop anything or replace anything. Choose, this is step feature engineer. So already moved to feature engineer. We choose the model or the features that already or apply our domain knowledge. What is the feature that useful? So we pass it to our model. I choose 4 features and drop the rest. The label will be price, and this is the features. So now we have label and feature. We need to split our data for training test. So this is method already exists that apply split. So this is that we pass the feature. This is the feature. This is split to xtrain and xtrain and xtest, and the label is split to y train and y test. Now we build the structure of model. We use Keras. Keras now already exists in TensorFlow. We can import it like here. We import Keras from TensorFlow, or we use TensorFlow.keras. So already from Keras sequential with sequential model. But our first layer, this is the first layer. This is the first layer, dance layer. We got the unit and activation function. I choose relo and input shape. Then the hidden, this is the hidden layer, and this is the output layer. We can put more than hidden layer. best I use or I choose just one hidden layer. This is based on your experience. Feature engineering layer is based on our experience. Try to reach to the best case. So like here, try to get the best score. Feature engineering or training model, add layers or remove layers, hyper tune your parameter. Okay, optimizer. I use, there are many optimizer. I use RSM Pro. Compile, I choose, because this is regression. So regression, if you return the slide, regression, use, this is matrix of regression. Yeah, I use mean square error, or you can use any matrix related regression. So I use absolute, mean square error, and mean square and mean absolute error. This method return the model. So if here I create an instance from this model. So now our model ready to fit. I use the method called fit. This is the step of training. Pass the X train and Y train and define the opposite. So you can fine tune. I choose 100. You can use, for example, 500 or 1000, based in your experience, or your. You can't choose any number. So that's up to you. So here, train our model. Our model ready for predict. For predict, we use, okay, for predict, use model predict. For training, model fit. Okay, this is the simplest method in the Keras. Model.fit, model.predict, and pass X test. So now, like exam, we learn our model. Now we want to test and evaluate our model. So give our model the exam and see the result of exam. The question is in X test didn't see unseen data. So now we are ready to evaluate how our model do in this exam. So we choose random number, and this is the price that predict, and this is the real price. Let us go to evaluation. The accuracy. So the mean square error, this is the number of mean square error, and this is the loss, and this is the absolute error. You can try and iterate, try to get the best or optimal accuracy or optimal result. Next, visualize the result. So in regression, if the data be very close to this fit, that's better. So this is the visualize, because it's not enough. It is not 9, it is 6. So the result like here. So if we reach to the optimal case or satisfy our result. Now ready to save our model. For save, model.save. So please remember model.fit, model.predict, model.save. Very easy. And get the name of our model. Here we need to install a requirement, which is TensorFlow.js. So here Python, I need TensorFlow.js to convert from Python to JavaScript. So this like a library which need to convert from Keras or TensorFlow, which built with Python, to JavaScript, TensorFlow.js. Now we want to create model. So this is the command to create model. Now this is the command from TensorFlow.js to convert our model. So we need first argument input format, which is Keras, then the name of our model or the path, because we are in the same path. So just save it, the name of our model. Sometimes we need the full path of our model and the path of the output model, which the folder that already created. So now if you click here, this is the folder which created, and because I already run the code, this is the two file that after converted. Now we zip this folder and download. I think here it's clear when I download. Okay, I will download again. Okay, allow. Now I download the model. So now model already to put it in our website or our folder. We create HTML page, HTML and JavaScript. We need to put this tag, which like import TensorFlow JS in our page. Then maybe this is the script in the same page or external file. So I put the JavaScript model. This is like input, like in this step. We need input to predict. I wrote it by JavaScript. This is step. We need input that collect the same feature vector. So we need here we in the step of select features or feature extraction, we define or we choose four features. So in prediction we need four. Collect four value, input collect four input value. So in this step, I build the JavaScript that get the data. This is the form which collects the data. Let us click here. I think here will be. Okay, no, wrong. Source, yeah. This is the body, the form which collect input data, type, number. Okay. So just 1 minute. I hope my voice clear. Here input, input data, form to input data, and button. Then we use this method to load our model, which exists in the same folder, model. So load the model and load this file, which connect here the weight and here the like JSON, which is connect with our page and the weight of the model. Just that's it. So yeah, just then when click, there are listener here, listener. When click, this is the model. This is the function which load. When load, we call this initialize function, which import our model, which exists in the folder model.json, which get in information and wait. So that's it. Any question?
Yeah, it seems that you have explained everything so clearly, so we have no questions. Thank you again, Ruqiya, for joining us. And I encourage everyone to join our next meetup in a week, when Bartek will tell about Firebase and Google Play Core libraries. Okay, so thank you very much, everyone, and see you in a week.